Well, let's look at the definition of linear transformation. A linear transformation is a function between two vector spaces that satisfies two additional properties, this one and this one. Basically, it says that if you have t of two vectors in the domain, you can do t of one plus t of the other. And this says if you have t of a constant times one of the vectors, you can factor that constant out front. If the function satisfies these two things, it's a linear transformation. If it doesn't satisfy it, it's not. The 3 Blue 1 Brown video that I recommended does a good job of explaining this stuff. I've got an example here, and then I've got two non-examples. Let's play with the non-examples first. We want to show that this is not a linear transformation. And the thing that makes this one not a linear transformation is this 1 here. If you were to take, let's pick two random vectors in here. Let's say that vector u is 3, 4, and vector v is 2, 2. We're going to see that this doesn't work. If we take f of u plus v, well, what is that? If you take u and v and add them together, you get f of 5, 6. And what is f of 5, 6? Well, according to the rule here, it's going to be 11, 1. Okay. Now, if we do f of u1, or I'm sorry, f of u plus f of v, we're not going to get the same thing. Because f of u is going to be, let's see, f of u is going to be f of 3, 4. Let me write this down. Then f of 2, 2. All right, f of 3, 4. That's going to be 7, 1. And f of 2, 2 is going to be 5, 1. And if you add those guys together, you get 12, 2. And that's not the same. This makes me think that I have made an error. F of 2, 2. Oh, that's supposed to be a 4. 4, 1. Because this first number is the same, 11. But the 2 there is this and this are different. So therefore, this is not a linear transformation. And I'm not going to do the next example because the next example is very similar. But anyway, this fails here. It also fails if you looked at the multiplication part. If we took f of u, let's say we did f of 3 times u, and let's compare that to 3 times f of u. Okay, f of 3u, that's going to be f of 9, 12. And what is that? That's going to be 21, 1. Whereas if I do 3f of u, that's going to be 3 times f of 3, 4. F of 3, 4 is going to be 7, 1. And when you do 3 times that, you get 21, 21, 3. So this and this are not the same. So therefore, it's not a linear transformation. Example 203, I'm not going to do it because it's almost exactly the same. And again, the 3 is the thing that's going to mess it up. Now this example up here that is a linear transformation, if we wanted to show that in gross detail, what we'd have to do would be pick two arbitrary vectors. I'm going to let u be AB and v be xy, or no, CD. And we would want to show these things. T of u plus v let's see, u is AB, so that's T of AB plus CD. That's t of, you can add those together. So you get a plus c, then b plus d. And if you work that out, what you wind up getting is, let's see, t of a plus, so I'm plugging in a plus c for x and b plus d for y. So this first entry is going to be a plus c plus b plus d. And the second entry is 2x, which just means 2 times this. So that's going to be 2a plus 2c. Okay, so we get that for t of u plus v. If we come back and we also do t of u plus t of v, since this one is linear, it's going to work out. T of u is t of ab plus t of cd. I guess I should technically have double parentheses on these. Let's see, t of AB is going to be, when we plug in A and B here, we're going to get A plus B and then 2A. And t of CD is going to give us C plus D and 2D. Or no, 2C. And when you add that up, you get A plus B plus C plus D. Then you get 2A plus 2C. So you get the same thing. And we could get, technically, if we wanted to prove that this is a linear transformation, we'd need to do that for the constant as well. But anyway, linear transformations just have these nice properties. And the sort of end result of this is that linear transformations can be described using a matrix, and they can also be, if you put in a line, they will put out a line, or possibly just a point. We'll talk about that more later. I think I'm going to stop here, and we'll look at the transformations by matrices in the next video.